Hello my dear students, welcome to the second part of previous year question discussions from the unit Kinematics. In this video, we are discussing the most important questions from the chapter Motion in Straight Line and Motion in Plane. And here comes the very first question for you. The question says, for a train engine moving with a speed of 20 meter per second, the driver must apply brakes at a distance of 500 meter before the station for the train to come at the station, come to state of rest at the station. If the brakes were applied at half of this distance, the train engine would cross the station with a speed of root x meter per second. Then what is the value of x? So let's understand the question first. Let this be a point and let this be the station. This point is at a distance of 500 meter from the station. Now if the driver managed to apply the brake here, while reaching this particular point, the train can be at state of rest. Now anyhow, assume the driver forgot to apply the brake. Okay, and once the train is here, that means exactly the midway between the earlier point and here. Of course, we can mark this distance as what? 250 meter. Here only he managed to apply the brake. So with what speed the train will be crossing the station? That is the question. Now let's try to understand what is the key concept or how we can proceed to the final answer. If we know the speed here and the acceleration, the retardation of the brake, of course from the formula v square equal to u square plus 2as, we can get the value for v. Now here, what all are the values that we initially need? We need the speed here, that is u, that is given as 20 meter per second, and distance, that also we know what it is, 250 meters. So the only unknown value is the value of negative acceleration or retardation, we can say. Now how to get that value? It's already mentioned that if the driver managed to apply the brake at a distance of 500 meter away, then the final speed at the station is going to be 0. So from that information, we can easily calculate the value of what? Acceleration. Okay, then we will substitute that over here. That is how we are going to proceed to the answer. I believe the key concept is clear. Now let's move to that. So we are going to get the value of a first. Okay, let me apply the equation v square equal to u square plus 2as, because what I know is the distance, initial speed and the final speed. So the final speed is 0, so here this is going to be 0. Initial value is what? 20 square. So it is 20 square plus 2 into acceleration into distance is what? 500. It's 500 meters. So of course this is 1000, so this is coming to the left. So minus of 1000 into a, that's equal to, here this is going to be what? 400. Alright. So of course this one and this one will cancel each other. Acceleration a, that's going to be what? Minus of 4 by 10, or this can also be written as minus of 2 by 5. So now we got the value of what? The negative acceleration, that is 2 by 5. Now we need to get the speed value here. So for that, what is this distance? Distance is 250 meters. The speed at this particular point is of course 20 meter per second. So what is going to be the final speed here? That is the question. And acceleration is what? 2 by 5 in the opposite direction. We can say retardation is 2 by 5. So v square, again the same equation, v square equal to u square plus 2as. U square is 20 plus 2 into what is acceleration? Is minus of 2 by 5. Okay, into what is the distance? Distance left is 250. Distance left is 250. Alright, now have a look. Here this is 400. Okay, minus of, here this is what? 2 to the 4. Alright, into 250. Okay, 2 2s are 4 into 250, all divided by 5. Is that okay? Now, if I check here, this is going to be what? Here, if I go for the cancellation between these two, here this is going to be 5. And 5 4s are 20. So, here this is minus of 200. So, V square, that is equal to 400 minus of 200, or I can say V is equal to root of 200. Okay, now let me cross check with the question. They says that it is root of x. So, V is equal to root of x, what they are saying. So, x is equal to what? 200. Okay, hope that was okay with you all. Now, let us move to the next, that is question number 2. A tennis ball is dropped onto the floor from a height of 9.8 meters. Okay, now if it rebounds to a height of 5 meter, ball comes in contact with the floor for a time duration of 0.2 second, the average acceleration during the contact is. Let's try to understand the question first. A ball is dropped from a height of 9.8 first. It will come in contact with the ground, and after that this rebound to a height of what? 5 meters. Rebound to a height of 5 meters. As per the question, the ball was in contact with the floor for a time duration of 2 by 10 second. 2 by 10 second, and what they want to know is, they want to know about the average acceleration. So, of course, to know about the average acceleration, the key concept is, once the ball come here, the velocity is v1, and once it go back, the velocity is v2. Okay. Now, final velocity, that is v2 vector minus v1 vector, that is delta v vector. Okay, and this change happens in a time duration of delta t. This is the time of contact. Now, acceleration A, that is supposed to be delta v upon delta t. This is the key concept of the question. Okay, so our target is, as far as from the question we know the value of delta t, okay, but we don't know about delta v here. So our first target is to get the value of delta v. Of course, to get the value of delta v, we need the value of v1 as well as we need the value of what? v2. How to get the value of v1? The ball is dropped from a height of 9.8. So traveling through a distance of 9.8, what's going to be the value of v1? That we can easily calculate from the formula v square equal to u square plus 2s. Using the same formula, this is again going to height of just 5 meter. So final velocity is 0 here. We can calculate what is v2. I believe that is clear. Now let's go ahead with the calculation part now. So first of all, it's being dropped from a height of 9.8. So I can say that v1 square, that is equal to 0 plus 2 into 9.8 into here, the acceleration due to gravity can be taken as 10. So into 10, v square equal to u square plus 2 into a into s. Okay, so here this is v1 square equals, here this is coming as what? 98 into 2. Alright, so here this is 8 2s are 16, we are left with 1, 9 2s are 18 plus 1, it is 196. Alright, so we are getting it as 196. So v1 square is equal to 196. Okay, now it's going to a height of what? 5 meters. Okay, it's going to a height of what? 5 meters. So there I can say that 0 equal to v2 square minus of 2 into acceleration due to gravity is 10 into height is what? 5. Okay, now it's clear, 5 2s are 10 and 10 10s are 100. So v2 square equal to 100. alright, V2 square equal to 100. And see, now have a look. What is V1? Of course, here this is supposed to be what? 14. That means from here I can say that V1 is equal to 14. Alright, and what about this one? V2, that's coming as what? 10. V2 is coming as what? 10. Now, what about delta V? Delta V, it is supposed to be V2 vector minus of V1 vector. Okay, V2 is 10 upwards. Alright, and what about V1? V1 is 14 downward. 14 downward. Okay, so from here I can say that delta V, that's equal to 24. 14 downward, that is why I took it as minus. Okay, so it's delta V is what? 24. Now what about the acceleration? Acceleration A, that need to be equals to what? Delta V upon delta T. What is delta V? We got it as 24. And what is delta T? Delta T we got it as 2 by 10. 2 by 10. So here I will be getting it as what? 120. So acceleration A is coming as 120 meter per second square. I believe that was okay with you. Now let's move to the next, that is question number 3. Question says, a horse rider covers half the distance with a speed of 5 meter per second, and the remaining part of the distance was traveled with a speed of 10 meter per second for the half the time and 15 meter per second for the other half of the time. The mean speed of the rider average over the time duration is x by 7. Then the value of x is, that is a question. Let's try to understand the question first. This is the entire trip and that is divided into 2 equal parts like this. The first half of the journey is being completed with a speed of 5 meter per second. Now for the remaining half of the journey, out of the total time, first half of the time is covered with a speed of 15 meter per second. And second half of the journey is covered with a speed of 10 meter per second. It's like this. First half is covered with 10 and second half is covered with 50. Okay, but the average speed calculation doesn't make any difference. Now what they are asking for is, they are asking for the average speed for the total journey. So the concept is, if for a total journey, if first half of the time is covered with a speed of V1 and second half is covered with a speed of V2, then in that case V average, that is supposed to be what? V1 plus V2 by 2. Okay, now if out of the total journey, if first half is covered with a speed of V1, I mean distance I am telling, not about the time. If first half of the distance is covered with the speed V1 and second half is covered with the speed V2, then the average speed is 2 times V1 V2 upon V1 plus V2. This is the key concept. Now how to apply this case concept in this case? So we need to deal with this part first. Here out of the total time, first half time is traveled with the speed of 10 and second half time is traveled with the speed of 15. So for this particular journey, the average speed is going to be 10 plus 15 by 2, that is 25 by 2, that is supposed to be 12.5 meter per second. Now I can redefine the case like this. This is the total journey and the first half of the journey is being covered with the speed of 5 meter per second and second half is covered with the speed of 12.5 meter per second. So for me this is new value of V1 and this is the new value of V2. Now V average is going to be what? V average should be 2 times V1 V2 upon V1 plus V2. And here this is 2 into V1 is 5 V2 is 12.5. All divided by V1 plus V2 is going to be 17.5. Okay, 5 2s are 10. So I can mark this as 125 divided by 17.5. This is the average value. As per the question, it is marked as x by 7. So I am going to mark this as x by 7. X by 7. Okay, we need the value of what? X. Okay, so x is supposed to be now, x is now supposed to be 125 into 7 all divided by 17.5. Okay, let me multiply with 10 here and divide with 10 here. Okay, so here this is going to be 175. Now of course 175 divided by 7 I am trying. So of course 7 2s are 14. I am left with 3 here, 5, and 7 5s are 35. Okay, so I can mark this as what? 25. 25 into 7. Okay, so this one and this one will cancel each other. So here this is going to be what? Here this is going to be 5. Now what is the value of x? Now I can say that x is equal to 50. X is going to be 50 here, fine. So I can mark it as 50 by 7 equal to x by 7. I believe that was okay with you. So here comes the next, that is question number 4. The position time graph for two students A and B returning from the school to their home are as shown in the figure. Now options are, option A says A lives closer to the school, B lives closer to the school, A takes lesser time to reach the home, A travels faster than B, and B travels faster than A. 5 options are there. Now let's try to understand the graph first. Here this is the position of the school, origin, and A reaches the home in this time. So this is time taken by A, and here this is home of A. So the home of A is at this distance. Now of course B start late, and time taken by B is this much only. This is time taken by B, and this is the position of home of B. So the home of B is at greater distance compared to that of A. So home A lives closer to the school. This statement is correct. And B lives closer to the school. This statement is wrong, because this is the distance towards home of B. So that statement is wrong. Now option C says A takes lesser time. Here this is the time taken by A. So that statement is again wrong. Okay. Next one is A travels faster than B. Option D says A travels faster than B. So who is traveling faster? For that we need to check the slope. So here slope of A is less than slope of B, which means if they say that A is traveling faster, that statement is also wrong. And I told you slope of B is greater, that means statement E is correct. So it need to be A and E only, that means option 1 should be the correct answer. Alright, I told you in a perfect way how to cross check the informations given, and you need to be very careful with those details. Okay, next is question number 5. Question says a projectile fired at an angle of 30 degrees to the ground is observed to be at same height at 3 seconds and 5 seconds after projection during its flight. The speed of projection of the projectile is. So we need to find out the speed of projection. Here I have got a very important information for you. if this is the projectile, they says that when time is equal to 3 seconds and 5 seconds, they are at same height. So I am going to mark that 2 time as this. Here this is t is equal to 3 seconds and here this is t equal to 5 seconds. Now of course, I have got equal time interval for these 2 time journey, and that is 1 each, which means t equal to 4 seconds is the time taken for half of the journey. So t half, general expression for t half, what it is? U sin theta by g. Total time is 2u sin theta by g and t half is u sin theta by g. Okay. Now what is that t half? T half is 4. Acceleration due to gravity, I am taking it as what? 10. That is equal to u into sin 30 is what? 1 by 2. Okay. So here this come towards the left, u is equal to what? 80 meter per second. It's as simple as that. Now let's move to the next, that is question number 6. Question number 6 says 2 trains A and B of length L and 4L are traveling into a tunnel of length capital L in parallel tracks from opposite directions with velocities 108 km per hour and 72 km per hour respectively. If train A takes 35 seconds less time than train B to cross the tunnel, then length capital L of the tunnel is, and given that capital L is equal to 60 times small letter l. So basically we need to calculate the value of capital L. So let this be the tunnel. Let this be the tunnel and let this be the 2 tracks. Okay, fine. Now once the train A cross the tunnel, so of course here the train will enter and here the train will leave. So here this is the point where the engine enter the tunnel and here this is the guard room. So guard rooms will be leaving this particular point. So once the guard room leave the tunnel, then we can say that what? The train has crossed the tunnel. So I take the engine as the reference. So engine travel from here to here for train A. So what is the total distance traveled by the engine now? The total distance traveled by the engine is length of the train is small letter l and length of the tunnel is capital L. So distance traveled by train A, that is small letter l plus capital L. In the same way, train B is coming from here and here this is the guard room of train B and here this is engine of train B. Alright, here this was engine of train A and here this was guard room of train A. So that train enter here and once leave, this is the situation. Here this is engine of train B and here this is guard room of train B. And what is the length of this train? That is 4L. So I can say from entering till leaving, the total distance travelled is L plus 4L. So distance travelled by train B, that is 4L, that is the length of the train, plus here this is capital L. Okay. Now time taken by train A, that is supposed to be the length, that is L upon capital L, all divided by speed of A. Similarly, time taken by train B, that need to be what? 4 times L into capital L divided by V of B. Okay. Now the train time difference between these two is given as 35 seconds. Now from here we can get the value of L and from there we will get the value of capital L. That is the method what we are going to follow. Yes. Now let us proceed with the calculation part. While proceeding with the calculation part, first of all let us identify what was the speed of train A. Speed of train was 108. So 108 km per hour. So 108 into 5 by 18, isn't it? Here this is going to be what? Here this is going to be 6. Yes. And so this is going to be 30. So VA is equal to what? 30 meter per second. And what about VB? VB is 72 kilometer per hour, isn't it? 72 into 5 by 80. Here this is 4. So here this is 20 meter per second. 20 meter per second. Alright. So if I go ahead with the calculation, TA, that is equal to, capital L can be taken as 60L. 60L plus L is 61L. 61 times L upon, here this is 30, and TB, that is equal to 60 plus 4, that is 64L. 64L divided by 20. As per the question, TA takes lesser time than TB, and that is 35, which means TB is greater. So TB minus TA, that is equal to, here I can go for L by 10 as common, and here is going to be 64 by 2, that is 32, minus of, here this is going to be what? It's going to be 61 by 3. Okay, so here this is what? 35. That is equal to L by 10 into, here I can have this as 96. 96 minus of 61 all divided by 3. Okay, so here 96 minus of 61. Okay, 96 minus 60, that is 36. 36 minus 1 is 35. So here this is 35. So 35, that's equal to L into 35 all divided by 30. This one and this one will cancel each other. So L is going to be what? 30. L is going to be what? 30. And we have got the relation as capital L is equal to 6 times small letter L. So finally, capital L, that equal to 6 times small letter L, that is not 6 times, 60 times. 60 into, what was small letter L? Small letter L was 30. 6 3s are 18. So 1800 is the final answer. That means option C must be correct answer in this case. I believe you got it right. Okay. Now let's move to the next. That is question number 7. The question says, a passenger sitting in a train, capital A, moving at 90 km per hour, observes another train, capital B, moving in opposite direction for 6 seconds. Okay, if the velocity of train B, is 64 km per hour, then the length of train B is, that is the question. Let's understand the question first. Let this be train A. Okay, and let this be the position of the passenger. And passenger see the train B here. He sees the engine here. So here this is train B and here this is train A. So from here his observation start. Of course this train is moving in the forward direction. So after some time, let that train A be here and let this be the passenger, and the engine crosses like this. I mean the guardroom crosses like this, not the engine, guardroom crosses like this. Now from here onwards he is unable to see the train. Okay, now of course from here to here, from this particular point to this particular point, from here this particular moment to this particular moment he was observing the train. Okay, fine. Now the question is, he was able to see the train for what? 8 seconds. So basically the train, the relative distance that he crossed is exactly the length of the train, isn't it? Relative distance that he crossed is length of the train. Okay, that means with respect to this particular person, this much length has just crossed. Are you getting me? So, and that length crossed is that we need to find out what it is, length of the train B. That is equal to, now in this case VB was moving in this direction, VA is moving towards right. Okay. Now train A, it was moving the speed of 90 km per hour and train B is moving the speed of what? 54 km per hour in the opposite direction. So if we consider the relative speed, that is going to be what? That is going to be 90 plus 54. Alright. So here this is going to be what? This is going to be 4 and here this is going to be 144 km per hour. Kilometer per hour. Okay. And here this is going to be 144 into 5 by 80. So here this is supposed to be 8, isn't it? Let's check it. 18 into 8. Yes, it's 8 and this is supposed to be 5 fours of 40 meter per second. So the relative speed is what? 40 meter per second. So 40 meter per second into what was the time allotted? 8. Alright, which means here it's supposed to be what? 320 meters. So the length of the train is what? 320 meter. Was that okay? Now let's move to the next, that is question number 8. The question says a particle starts from origin at t equal to 0 with velocity of 5 meter per second I cap and moves in xy plane under the action of a force which produces a constant acceleration of 3I plus 2j meter per second square. If the x coordinate of the particle at the instant is 84 meter, then the speed of the particle at this time is marked as root of alpha meter per second. Then the value of alpha is. You must understand the body is starting from origin and initially it is having a velocity of 5 meter per second along I cap only. And this particle is experiencing an acceleration of 3 I cap plus 2 j cap. Now the question is, when the particle is at x equal to 84, what is its speed? That is the question. Okay. So of course, while considering the key concept, when the particle is at x equal to 84, it will be having a Vx and it will be having a Vy, and the magnitude of the speed V, that is going to be root of Vx square plus Vy square. That is going to be the speed. Okay. Now, of course, we need to know about Vx and Vy. To get the value of Vx, we all know that final velocity square, that is V square equal to U square plus Vx square equal to Ux square plus 2 times Ax into S of x. And what is Ux square? Ux square is 5 square, because Ux is 5, Ux square is 5 square, that is 25 plus 2 into what is acceleration along x axis? Acceleration along x axis is marked as 3. So I am going for that, 3 into displacement along x axis. Displacement along x axis is 84. Okay, so here this is 3 2s are 6. So 84 into 6. First of all, let's deal with this. 84 into 6 is going to be 4, 2, and here this is 5 8s are 6 8s are 48 plus 2 50, 504, and 504 plus 25 plus 25. So here this is going to be 529. Here it is 529. So Vx square, it's coming as 529. Okay, Vx square is coming as 529. And what about Vx now? Vx is going to be 23. It's going to be 23. Okay, now to get the value of Vy, we must know within what time the velocity along x-axis got increased from 5 to 23. From there we will get the time gap, and we can consider the same time gap along y-axis to get the value of velocity along y-axis. So of course, velocity along y-axis, that need to be initial velocity along y-axis into velocity along x-axis need to be initial velocity along x-axis into acceleration along x-axis plus time taken. Here we know that this is what, 23, and here this was what, 5, plus acceleration along x-axis what? Acceleration along x-axis was 3. Okay, acceleration along x-axis was 3, so I can substitute that, and time taken is t. So this will come to the left. 23 minus 5 is 18, 18 by 3 is 6. So t is equal to 6 here. T is equal to 6 here. Now within this time gap, what is the velocity increase along y-axis? That is what we need to find out. So velocity along y-axis final need to be initial velocity along y-axis plus acceleration along y-axis into time taken. And we all know that initial velocity along y-axis was 0 and acceleration along y-axis is how much? 2. So here this is 2 into time taken is what? 6. So here this is what? 12. Velocity along y-axis is what? 12. Okay. Now we know Vx as well as we know Vy, isn't it? That means we know Vy as well as Vx. So here the final speed, okay, this is Vx and here this is Vy, and we need the resultant. So the resultant is going to be root of Vx square plus Vy square. That is root of, what is Vx square? Vx square is 529. So it is 529 plus, here this is what? 12 square, that is 144. 144. So the final answer is going to be root of 529 plus 144. Alright. So 9 plus 4 is 13, left with 1 here. 4 plus 3 is 7 and 5 plus 1 is 6. So the final answer is going to be root of 673. Checking with the option, alpha need to be what? Alpha need to be 673. I believe that was okay with you. Now let's move to the next, that is question number 9. Question number 9 says, a body falling under gravity covers 2 points A and B separated by 80 meters in 2 seconds. Then the distance of the upper point capital A from the starting point is. So here this is the tower. Let this be point A and let this be point B. As per the question, these points are separated by a distance of 80 meters. They are separated by a distance of 80 meters and the time taken to travel from here to here, it is 2 seconds. It is 2 seconds. Now let me consider the body is dropped from here. So let this distance be say h and the time taken to reach from here to here, it is t. So if I consider, so this is A and this is B, isn't it? And let me take this as O. First of all, let me consider the journey from O to A. So while considering the journey from O to A, I can say that h is equal to u is 0, half of acceleration due to gravity is 10 and time taken is going to be t square. So I can say that h is equal to 5 times t square. Okay, I repeat, here this is the journey is from O to A. Now if I consider the journey from O to B, I can say that this time the distance travelled is h plus 80 and that is equal to what? That is equal to, again u is 0, half of What is acceleration here? Acceleration is again 10 only. And time taken is from here to here it is t, and here to here it is 2. So it is 2 t plus 2. So t plus 2 the all square. Again I can say this is equal to 5 into t plus 2 the all square. We have got the expression for h here. What it is? 5t square. Let me substitute that here. 5t square plus 8t, that is equal to 5 into, once I open the bracket, here this is going to be what? T square plus 4 plus, here this is going to be 4 times t. If I open the bracket, here this is going to be 5t square plus 8t is equal to, here this is going to be again 5t square plus 5 4s are 20, alright. Once this go in, 5 4s are again 20 times t. Okay. So 5t square and 5t square will cancel. Let me take this 20 towards the left. So on the left hand side it's going to be 60. 60 is going to be 20 times t. So here this one will cancel each other. So t is going to be what? 3 seconds. So t is going to be 3 seconds. Now the question is, as per the like what they are asking for, they are asking for the distance of OA. So OA is the distance traveled in 3 seconds basically, isn't it? So there SOA, that is equal to 0 plus half of A is 10 into t square means 9. So here this is going to be 5 and 9 5s are 45 meter. So the answer here is going to be what? Distance travel is going to be just 45 meters. Let's move to the next, that is question number 10. Question number 10 says, a ball rolls off the top of a stairways with a horizontal velocity of small letter u. Okay, the steps are 0.1 meter high and 0.1 meter wide. The minimum velocity small letter u with which that ball just hits the step 5 of the stairways will be root of x meter per second. Then what is the value of x? That's the question. So let this be the first, second, third, fourth, fifth, like those score. Okay, now 1, 2, 3, 4. That means it is just hitting here. Alright, now have a look. The vertical height traveled is 1, 2, 3, 4. So displacement along y axis is 4 into 0.1, that is 4 by 10. Okay, that can also be marked as 2 by 5. Now have a look. Displacement along y axis is equal to initial velocity along y axis is 0 plus half of acceleration along y axis, I am taking it as 10, okay, into time taken is t square, and we all know about s of y, what it is, 2 by 5. So 2 by 5, that is equal to 1 by 2 into 10, okay, into t square. Rearranging this, here this is going to be 2 into 2 all divided by 5 into 10, that is equal to what? T square. This one and this one will cancel each other, this is going to be 5. Okay, so basically the time taken t, that is equal to what? Root of 2 by 5. Okay, this basically time taken is going to be root of 2 by 5. Alright, now if I consider this particular horizontal distance, there it is 1, 2, 3, 4. Okay, in that condition the horizontal distance is going to be what? Again 4 by 10. That is equal to u into what's time taken? Time taken is root of 2 upon 5. As you all know that this one and this one will cancel each other, this will leave 2 here, this one and this one will cancel each other, that will leave 2 here. Now u is what? 2 by root 2, that is equal to root of 2. which means x is equal to what? X equal to 2 here. Fine. Now let's move to the next. That is question number 11. Question says the displacement and the increase in velocity of a moving particle in the time interval of t to t plus 1 second are 125 meter and 50 meter per second respectively. Then the distance travelled by the particle in t plus 2 second is. So let this be the time t, and here the time is t plus 1 and here the time is t plus 2. So in this particular distance, in this particular time duration, the distance travelled is how much? 125 meters. And here the time duration is equal to what? 1 second, t plus 1. And in this 1 second gap, the velocity is increased by 50 meter per second. So which means the acceleration here is what? Change in velocity, that is 50, divided by time taken, that is acceleration, time taken is 1. So acceleration is what? 50 only. Acceleration is 50 only. Now let's go for this calculation. If I consider the journey from O to A and then towards B. So first of all, I am considering the journey from O to A. Their distance traveled is 125. I am going for the relation s is equal to ut plus half at square. The distance traveled is 125 plus u, I don't know, I am marking it as u. Time taken is 1. So u into 1 is u plus half of acceleration is what? Acceleration is 50 into time taken is again 1. So here this is what? 50 by 2 is 25. 25 come towards the left. It's going to be 100. So u is going to be what? 100 here. U is going to be 100. Now I am going to consider the journey from O to B. I am considering the journey from O to B. So SOB, that is u value we know, it is 100. Again I am going for the relation s is equal to ut plus half at square. Here the time taken is 2 seconds. So 100 into 2, that is ut plus half of acceleration is 50 into time taken square means 4. Okay, this one and this one will cancel, it's going to be 2. So here this is going to be 100. So SOB, that is going to be 2 into 100, that is 200, and I have got 100 here. So that distance is going to be what? 300. So this distance is 300, this is 125. So this particular distance, it is supposed to be what? 300 minus 125, that is 175 meters. Alright, so the final answer is going to be 175 here. And here comes the last question, question number 12. The question says the relation between time t and distance x is given as t equal to alpha x square. T is equal to alpha times x square. Okay, sorry, alpha times x square plus beta x. That is the relation, isn't it? Where alpha and beta are constants, the relation between acceleration a and velocity v is, that's the question. Okay, what I am going to do here is, let me take dt by dx. What is going to be dt by dx? Dt by dx is going to be, if I differentiate this, what this is going to be? Here this is going to be 2 times x into alpha. If I differentiate this, this is going to be 2 times x into alpha plus beta, and you know that this is 1 by v. Okay, so I can write v equals to 2 times x into alpha plus beta raised to minus of 1, that is velocity. And we know that acceleration a, that is v into dv by dx. V into dv by dx. What is v here? V here is 2 times alpha into x plus beta raised to minus 1 into d by dx of, again 2 times alpha into x plus beta raised to minus 1, the differential of this. And here I am going to get this as 2 times alpha into x plus beta raised to minus 1 into differential of this is going to be minus of 1 into 2 times alpha into x plus beta raised to minus of 2 into 2 times alpha. Alright. So, here this is going to be minus of 2 times alpha into 2 times alpha into x plus beta raised to minus of 3, and here this is v cube. So, acceleration A can be written as minus of 2 times alpha into v cube, which means option A should be the correct answer. Alright. So, that was all from my side from the unit kinematics. We will meet soon with the discussion of important questions from another unit. Till then, bye bye and take care.